two cars are initially 1,200 miles apart. At the same time, car A starts driving 35 miles per hour to the east and car B starts driving 55 miles per hour to the north. At what rate is the distance between the two cars changing after A, 2 hours of travel, and B, 40 hours of travel? So we know that car A and car B are initially 1,200 miles apart, and car A is moving east and car B is moving north. Based on this information, we can make a triangle, so we draw our arrow east and our arrow north. We're not sure the distance of each side, but we will be able to figure that out. So the side A, we don't know, but the differential of A is 35 miles an hour because we know car A is moving at a rate of 35 miles an hour. We're unsure of side B, but we know the differential is 55 miles an hour, and that's the rate of change. And we're looking for the rate of change of C. So we can figure out side A by multiplying 35 miles an hour by 4 hours to get 70 miles. We can figure out the distance of B by multiplying 55 miles per hour by 4 hours, the time, to get 110 miles. So we still don't know what C is, but we can figure this out because we know A and B, so we could use Pythagorean theorem, which is A squared plus B squared equals C squared. So for A, we fill in 70 squared plus 110 squared equals C squared. We then can figure out that 70 squared is 4,900. We can figure out that 110 squared is 12,100. And we could solve then using algebra. So we'd have to take the square root of C and the square root of our answer to get that C is 130.4 miles. We can organize our variables. We know that A is equal to 70 miles, B is equal to 110 miles, C is equal to 130.4 miles. dA over dt is equal to 35 miles per hour, dB over dt is equal to 55 miles per hour, and dC over dt is what we're looking for. Organize all of our variables. We could use Pythagorean theorem, which is a squared plus b squared equals c squared. We could use the derivative, which is 2a times dA over dt plus 2b times dB over dt equals 2c times dc over dt to find our missing dc over dt. So now that we have our equation, we can plug in our variables. And then we can solve for dc over dt. So when you do the math, you can figure out that it is 4,900 plus 12,100 is equal to 260.8, and we're still searching for dc over dt. When we add up our left side, we get that the sum is 17,000, and then we can set that equal to 260.8. So now we want to isolate the dc over dt by itself, so we divide both sides by 260.8. So after we divide our two numbers, we get dc over dt is equal to 65.8 miles per hour. So now we can write our sentence. After 2 hours of travel, the rate of change is increasing by 65.8 miles per hour.
So question letter B asks, at what rate is the distance between car A and car B changing after 40 hours of travel? Similar to the first question, we would have to draw a triangle to represent the entire situation and label letters A, B, and C as the three sides, and dA over dt as the speed of car A, dB over dt as the speed of car B, and dC over dt as the changing rate of distance. So we know from the original question that dA over dt, which is the speed of car A, is 35 miles per hour, and that the speed of car B, dB over dt, is 55 miles per hour. So in order to find the distance of letter A and letter B, we would have to multiply the speed times the amount of hours traveled. So for A, we would multiply 35 times 40 to equal 1,400 miles. And for side B, we would have to multiply 55 miles per hour times 40 to get 2,200 miles. So using the equations we just used, we now have the known values of the length of side A and the length of side B. So we can plug in 1,400 miles into side A and 2,200 miles into side B. Next, to find the length of side C, we can use the Pythagorean theorem. We know from algebra that the Pythagorean theorem can be used to solve the missing side, so with the equation a squared plus b squared is equal to c squared. We can use the values that we just solved for, a and b, and plug them into the equation to solve for c. So 1,400 squared plus 2,200 squared would be equal to c squared. We then find the value to be 1,960,000 for 1,400 squared and 2,200 squared to give us the value of
Yes, it definitely took up some time. For me, away from
4,840,000 to be equal to c squared. With those values added together, we get 6,800,000 is equal to c squared. We would then take the square root of c squared and 6,800,000 to receive the value of 2,607.68 miles to be the distance of side C. Now that we have our known values of the distance of car A, the distance of car B, and the distance between those two cars, we can fill in all of our knowns. So we have that A is equal to 1,400 miles, B is equal to 2,200 miles, and C is equal to 2,607.68 miles. We can then plug in the known derivatives. dA over dt is equal to 35 miles per hour. dB over dt is equal to 55 miles per hour. And dC over dt is the unknown and what we are trying to solve in this question. With this information, we can then use the Pythagorean theorem a squared plus b squared is equal to c squared, and take the derivative of that equation to get the new equation 2a times dA over dt plus 2b dB over dt is equal to 2c dC over dt. Now, having the new equation to find the derivative dc over dt, we can plug in all of our knowns and multiply 2 times 1,400 times 35 plus 2 times 55 times 2,200 is equal to 2 times 2,607.68 times dc over dt. Using basic algebra, we can multiply all of these values. So 2 times 1,400 times 35 would give us the value of 98,000. 2 times 2,200 times 55 would give us the value 242,000 is equal to 2 times 2,607.68, which would give us 5,215.36 dc over dt. Adding 98,000 and 242,000, we get the value 340,000 is equal to 5,215.36 dc over dt. We can now isolate dc over dt by dividing both sides by 5,215.36. So by dividing 340,000 by 5,215.36, we get the value of dc over dt to be equal to 65.19 miles per hour. Because for these related rate questions, we must answer the question with a statement, we can state that the changing rate of the distance between the two cars is increasing by 65.19 miles per hour.